Thank you guys so much for coming. This is the first official presentation of the Mandelbot Ecotech Surfa 2. This prototype is one that I worked on with the amazing and illustrious Mike Taylor from Uncanny Machines. He's an absolutely brilliant engineer, very, very shy, and he's probably going to be super embarrassed that I'm mentioning his name. But I just have to give him a huge shout out for being brilliant. And the predecessor of this was co-designed with Lucian Shapar, who's another absolute wizard. So I wanted to get started because we have a few minutes. It's going to be a quick presentation, but it's going to be very information dense. So Mandelbot Ecotech is a design philosophy, and it's a tool for transformation. Okay, who am I? Well, as Mario mentioned, I'm an inventor, an artist, environmental vegan activist, self-taught engineer, vegan snack maker. I do a lot of different things. I'm into ancient technologies. I like organizing concerts and talks and whatever it is that I'm interested in. I kind of dive in very, very deeply, like a lot of you guys here. Okay, so the origins of this come from the Groucho Fractal show. So Groucho Fractal is a thing that I created a while ago. I tour all over the world with it. It is a science comedy cooking show in which audience members use brain-computer interface to make 3D printed organic vegan snacks on a bike-powered 3D food printer. And then the audience eat the snacks. So back in 2010, I wanted to make this show, and I came up with the idea for all this different stuff, and I didn't know how to make any of it. I didn't, like hardly any of it existed, and none of it was really working together. So I met some really amazing people, including Virginia Ozymandias and Adolf Alexander, Jamie Schwetman, Daniel Taub, and all these other folks, Carl Kiefer, who helped make the show come together. And just helped me basically understand a lot of these kind of nascent and burgeoning technologies. So I also come from the DIY punk scene. I used to run a record label called Bloodlink, which was a kind of very early emo, straight edge vegan hardcore label. I ran the Lost Film Fest. I started Evil Twin Booking Agency 2 decades ago with my partner Liz. It still runs. And I also kind of come from protest culture and activism and stuff like that. Okay, so the inspiration for the project comes from RepRap, which is the idea of creating a self-replicating 3D printer. Adrian Bowyer at the University of Bath in England came up with this class in order to make a 3D printer using off-the-shelf parts and 3D printed parts way back in, I guess, in the mid-2000s, as a lot of patents were coming out of they were coming out of license, they were becoming open, like key parts. You could actually just create 3D printers, and that's actually kind of where a lot of this 3D printing revolution came from, because 3D printing had been available for decades before that, but it was only accessible to auto manufacturers, aircraft manufacturers, military, folks who could afford hundreds of thousands of dollars of equipment. Another inspiration comes from a local company called Prusa, Josef Prusa, who's a local, and I guess he's a big supporter of Parallelly Police, was a huge inspiration to me. If you look at the bot, you'll be able to maybe recognize some inspiration from the i3, which is one of their models. Super amazing project. And you can find some of the Prusa printers down in Bordel, which is the hackerspace downstairs. Earthship Biotecture, which is a project created by Mike Reynolds, which is, I guess, the idea of creating living self-contained domiciles made from trash. So there are these buildings made from tires where you have glazing on the south-facing window that allows you to have heat during the winter, and there are also vents coming into it that allow it to be cooled in the summertime. It's an amazing project to check out. The Whole Earth catalog was a thing that was very inspirational when I was a kid. It was, and you can find PDFs of it online all the time, and Coevolution Quarterly. These things were like very formative in terms of taking my opinions from just like a lot of the science fiction that I'd been reading and making it applicable to real life scenarios. Open source ecology, it's this idea of creating lots of different machine primitives that can be modular and put together. It's Marcin Jakubowski is the person who created that. Rhizome Collective, which was an Ecotec experiment that existed from 2000 to 2010 in Austin, Texas. Appropedia, which is still around. It's an appropriate technology wiki. And Arcosanti, which was a project created in the 1970s by Paolo Soleri, who is an architect, an Italian architect, and he created this idea for a sustainable city in the desert outside of Phoenix, Arizona. And you'll start seeing some of the inspiration in a lot of this stuff. Okay. A never-ending project. Spell check. It's a never-ending project. Oh man. Okay, true ideas will live forever regardless of business models. Oh my goodness. Spell check. Okay, so basically it doesn't cost anything to think. I always find it very frustrating when people are like, oh, we ran out of money, we have to like close the project. It's like, no, if you believe in the thing, you just keep it going no matter how much money is there. Like sometimes there will be money, sometimes not, but if there's an idea worth doing, you'll just do it. You won't care about the business model. The business model, the money is sometimes just icing on top of the cake. But if you really believe in what you're doing, if you have to live in a box and eat out of the skip to complete your project, you'll do it if you believe in it. Okay, so you'll see in a moment how this project has a lot of design constraints because the whole project is built around parametric design, which I'll get into in a moment. And thinking about everything as a resource rather than thinking of these things as trash. So when I look at a blender, I don't see a blender. I see a motor inside and I see controls. I see all kinds of things. When I look at a car, I don't just think of a car, like an application-specific thing. I think of lots of different simple machines and complex machines, circuitry. And I think that it's really important to be in the practice of dissecting every single thing that we see, to start thinking about everything as a resource so that we stop throwing things away unnecessarily and that we start actually respecting the environment and respecting the fact that so much energy went into just bringing us things like simple pieces of metal. Like, where was this mined? How was it mined? What were the political and social impacts of the mining? How did it come to be where it is? Was it shipped all over the planet? All kinds of things like that. So, yeah. And eliminating the idea of planned obsolescence. So one thing that is so upsetting to me is when we have machines where they will design aspects of the machine to deliberately break after a certain period of time. So frustrating. So the idea of creating things so that they're modular, so that you can swap in components, based on when there are new, new advancements or your tastes change or whatnot. So when we're designing machines, I think it's really important to kind of eliminate that idea of kind of, thinking of things as trashable at all, and thinking about how we can swap it out and how every single device should be some kind of scaffold that you plug components into. Okay, so here we go. I'm about to reveal to you the Mandelbot Ecotech Surfa 2. Okay. Da. Da. Thank you. Okay, so one of the things about this is that it is a Liberation Ecotech device. And what does that actually mean? Well, it means that when we put things together, we construct them from sustainably sourced materials. So what does that actually mean? Well, the plastic on this is actually a compostable bioplastic made from plants. It's a PLA. It's very easy to find. It's super common in terms of finding filament, this type of thing, and like when you're buying filament for 3D printers, it's also really easily recyclable. You can find compostable cups that can be very easily melted down and mixed with fresh filament, and then you can make new filament out of it. It's super versatile and great. And also, when we're thinking about sustainably sourcing materials, we want to think about reusing, recycling, and upcycling parts. So a lot of these parts actually came out of other things that I'd been making, just on principle. Like I wouldn't just order things on the interwebs and have them shipped to me. I would try as much as possible to actually reuse things from other stuff. Like, for example, this extruded aluminum and some other parts. The skateboard bearings in here came from other stuff. Yeah, there's lots of it. Now, the other thing, too, about this is that it is scalable. So I wanted to address the environmental crisis oriented around manufacturing and distribution of consumer goods by allowing people to have a set of plans so that they could make their own printer wherever they are in the world without having me ship it to them. So they could just download the plans, make it as if it was a kit. And I wanted people to be able to customize it. So I wanted to be scalable. So what I did was I created this series of nodes. So you can see all these different things here. Then some of these are static, and then you'll have things that are also dynamic. So the static ones are the ones that stay the same shape no matter what, and then you have dynamic parts that will change. So you can change all the dimensions in X, Y, and Z, such that you can create it in an application parametrically. So what that means is that you have certain sets of design constraints. So if you want to scale it in any different direction, you can put it into different types of applications, or you can make your own application like we're doing right now to allow you to scale it. Okay, and yeah, another thing about this is it's low power consumption. The whole thing was designed to be part of Groucho Fractal, which is an off-grid show, meaning that I power the entire thing by bicycle and battery. So the projector, the sound system, the printer, and all the other devices are powered off-grid. This is no exception. So this was designed to be low power. And it's also very easy to repair. Okay. So it is constructed with 3D printed and off-the-shelf parts. So all these parts are something you can order very easily and reuse from other things, as I mentioned. Mentioned that these nodes and connectors can be used for multiple purposes. One thing about this is that I'll get into this in a moment, but you'll see that there's the different types of axes. There's the X, and then there's the Y assembly, and then there are two Z assemblies. So while this is a 3D printer, you can also just use this entire Z assembly as a drill press. So you can basically lock it into place and then connect a drill here and have that come down and be a motor controlled precise drill. So multiple tool heads. So also I'm going to introduce to you a thing I worked on with Mike Taylor. This is the Goostruder 5. This is the fifth real prototype of the Goostruder, which is an extruder that extrudes goo. Yes, thank you. So in here I have nut butter. And so normally in the Groucho Fractal show I'll print nut butter onto cookies and other types of goo. You can use it for ceramic. You can use it as a lab tool, so printing with biological materials if you're going to do a whole bunch of, let's say, samples in Petri dishes. Also, there are other types of print heads that you can use for this. There's a plastreader that I'm working on. There's a mount for a Dremel, a laser, all kinds of things. You can basically do whatever you want. It is essentially a Surfa is a general purpose robotic gantry that sometimes has a fake mustache, fake mustache and a disguise as a 3D printer, but you can do a lot more with it. The other thing too in this, I hide lots of kind of Easter eggs. I don't know if you guys are Star Trek fans. I don't know if you can see the Enterprise. Okay, yeah. Anyway, so everything is also hot swappable. So I use very standard stuff. If you guys are into film, you'll recognize the mount here. It is a typical tripod mount that you find. You just kind of slap it onto there. It stays in place. It's pretty good. Also, here's another one of the features of the Surfa that's pretty nifty. Let me pull this out real quick. Okay, so I'm going to do this manually. Unfortunately, I'm not able to actually give a working demo of it because I had a lot of problems with it. There we go. But here, I'll show you. Okay. So one of the things about magnets and how they work, when we're at the Insane Clown Polytechnic Institute, we sometimes will have the ability to use these magnets. So how is this whole thing held together? Well, if you look at this thing, you'll notice that there are no metal fasteners holding the entire structure together. The reason for that is that I wanted to use connections I wanted to use things like tensegrity and interlocking concepts to come together so that it's all held together very, very simply. So at the end of all these different interlocking bits is a couple of neodymium magnets that hold the thing together. So basically I can take this whole thing apart and into the X, Y, and 2Z subassemblies very easily after I pull out the X carriage. Okay. You'll notice that there's a lot of symmetry in this. So there's there's symmetric, parametric, and palindromic design incorporated into that. And what does that actually mean? Well, this part is identical to this part. Not a mirror image, but it's identical. This part is identical to this. This part is identical to this. This are identical. And I try to use as much have as much identical feature on every single axis as possible. So whether it's X, Y, and Z, I try to have all those things accounted for so that everything locks together and that when I travel around, I don't have to have multiple spare parts. Or I can just very easily print one part in advance. And one of the important things also is that because this is a Cartesian, oops, sorry, because it's a Cartesian design, you wind up having all these different right angles. So that's great, but it also can be a potential problem. If you have two parts together and you're having it move around, you always want to have some type of triangular brace. So one of the things I figured out is that it's good to print a lot of these parts diagonally or orthogonally so that I'm actually creating a triangular piece right here. So you'll see that these parts are actually printed with that triangle in there. Okay. All the movements in this are easy to clean and swap out and very dust resistant where possible. So I go to Burning Man and a bunch of other festivals that happen in the desert, and I'm always thinking about, the dust is going to ruin everything. So I wanted to make it very, very easy to either lubricate or, just not have too many points of failure. Also, where all the stuff is very, very visible, so I could clean it up easily with a cotton swab or a tissue, whatever it is. Okay. The printhead is also self-locating, meaning that that if it's slightly off, it can like the printhead can basically go around to multiple points on the bed and self-level itself. Now, hole precision is really important here too. When you're designing this stuff in CAD, you want everything to line up perfectly. And also you want to think about the tolerances of the holes for the fasteners, so that everything fits in. Either you have a snug fit, a loose fit, and so that's really important to take a look at, especially when you're 3D printing parts. One of the things that you'll notice is that it's not a precision thing. Like sometimes the holes will be bigger or smaller than you intend. So so sometimes it's really good to really think through those types of facets. Precision mating. So this is a precision mating here, right here, with where the magnets go in perfectly. Everything slides into place. Everything's designed to move perfectly. Okay, and of course minimal metal fasteners. So the other thing too about this is that it fits standard stowage size and weight parameters for airlines. So the original Mandelbot printers were made to fit into a suitcase that I found in the garbage. This printer is no exception. So here's my very illustrious partner Liz Cole's pink suitcase. And I'll fold it up real quick and just show you how easily it fits in. Okay. Do. How am I doing on time?
You're over time, like 2 minutes.
2 minutes? Yeah, I can wrap up in 2. Okay. Anyway. Come on, fold. Oh, there we go. Even though in the future nothing works. There we go. This whole thing is going to break. Okay, I want to put it back together. There we go, thanks. Anyway, I won't waste time with this. I was going to put it into the suitcase. I'll do that later. Okay, do we have the clicker? Here we go. Okay, so it's portable, it's lightweight, it's folding, it's educational. So we end up having multiple types of motion and carriage systems that teach engineering. It's important to learn both mathematics and programming through doing this. So you're playing with an Arduino. I actually use an Arduino Mega 2560 with a Ramps 1.4 board and typical off-the-shelf Polulus. Why do I do this? Because the whole thing is about $7. And that makes it affordable anywhere in the world. If you're using really expensive microcontrollers and all the fancy stuff that with doodads you don't necessarily need, it can make it inaccessible to people. So I want this to be accessible all over the planet. Okay, so Symmetry, design is intentional, multi-purpose, lock and assemblies. Okay, I already said this. Okay. So what's been completed? So far I've done, over the past 12 years, I've made 35 prototypes that have led to this. All amazing. Some of them are the most ridiculous things I look back on. My friend and mentor Adolf Alexander challenged me to go as far as I could. And I was once very frustrated, and I said, I'm just going to look at some patents. And he said, if you look at some patents, I'm going to stop working with you. I'm like, why? And he's like, because I want you to imagine how this works. And seriously, I made some of the crappiest, most ridiculous things. But in the end, I wound up understanding how to create things like linear actuators and how to do how to create mechanisms. It's a really good way of kind of challenging yourself. So the Mandelbot Surfa 2 model is complete and it's ready for the smart contract aspect, which I'll talk about in a second. And also I'm working on a 3D printed eco-construction project. So it's like a giant 3D printer for printing with cob. That I've purchased land in Landers, California for doing prototyping there. And next thing I need to do is the technical documentation for this stuff, create the scalability app so you'll be able to scale this in the app, and then export it as a smart contract. So hopefully Mario will be working on that with me, and more R&D and prototyping. And I'm also working on designs for an electric vertical takeoff and landing vehicle, atmospheric water generation unit, blimps, things like that all follow the same design thing. So wanted to thank you guys so much for coming. I wanted to thank Parallel Nipolis and HCPP and Bordel and all you guys for coming. I don't know, do I have time for one question or should we go?
Thank you so much, Scott.
Thank you.
One question, yeah.
Okay. Yeah.
Considering the design and all the construction problems, how good are the tolerances in it, or do you have a fiddle like in your parametric design? Like, I want it to be, I don't know, like 0.05 millimeter or 0.1, and it changes something.
That's a fantastic question. So basically, the tolerances all wind up staying very static, and they're figured into the parametric design. So the static parts have they're all designed to have these types of tolerances for for nuts and bolts and that type of thing. Yeah. Okay. Yes.
Yeah. The last question. I am a newbie, so my question is: are you able to print a new machine with this one?
Yes, absolutely.
Okay. Wow.
Yeah. That's okay.
Self-replication, right?
Yeah, it's a self-replicating. Yeah, so check out RepRap if you're interested in that type of thing. There's so much stuff out there. It's an amazing project. Well, I wanted to thank you guys so much. If you want to check out the website, it's mandelbot.io. My name is Scott Beibin, and if you want to come and talk afterwards, yeah.
I'm sure you'll be hanging out here or in Bordel, and huge thanks again, Scott, and thank you, all of you, for listening.
Okay. Thank you, guys.
Actually, now you can watch Scott to fold it up because you have to take it from the stage. So I mean, I'll help you.
Here, hold on a second.
It really works. It really fits into the case.
There we go. Okay. Okay, if any of you guys want to plug into the project, it's open, and I'm trying to build a community right now, so you guys are welcome. Thank you.